All right, starting circular motion, arc length can be used to analyze circular motion. Suppose an object moves along a circular path S with radius R. So a circular path S right there with radius R right there. Okay? So the rate at which the object moves along the path is called linear speed. We're going to use V for that. And there's the formula below. The rate at which a central angle changing along the path is called the angular speed. So what's the only difference between those two formula? The R, right? So it's good to always just recognize that. Okay. So looking at number 1 and 2, a bicycle tire with radius of 14 inches rotates at a rate of 125 revolutions per minute. Find the angular speed of the tire in inches per minute. So you can plug in to the formula. V equals 2 pi times 14 times 125. Right, because they give it in revolutions per minute right here. So that's where the 125 came from. And the 14 is the radius. So you plug it in right there using this formula right here. So if we do it in terms of pi, we get 3,500 pi. Sometimes they want it in terms of pi, you just never know. And it's in inches per minute. And then if you multiply that by pi, you get 10,995.6, which is, I believe, what you said. Inches per minute. Okay, so we just found the linear speed. Now we're going to find the angular speed. So we're using the formula directly above number 2. So we have W equals 2 pi times 250 pi radians per minute. Or no, times 125. I don't know what I was saying.
Oh, okay, that makes sense.
Times 125. I looked at the answer by accident. So 250 pi radians per minute. And if we multiply the 250 by pi, you get 785.4. Question? So try 3 and 4 right below. I copied that formula down, right? Are you going to get this formula on your test? No, you're not. You do get a couple formula sheets in algebra in pre-calculus, because once we do the unit circle and we start doing trigonometric identities. Trigonometric. You can go home that night and tell your parents what you did, and they'll look at you like you got 2 heads. Trigonometric. Okay? So do 3 and 4. I'll freeze the screen, write them down up here. So just like the ones above. The only trick is, look right here. It says diameter of 120. So what do I have to do with that? Right? So we need 60 because it's just radius in the formula, not diameter. So you get divided by 2. And then you can plug stuff in. So pay attention, because that's a little trick they'll throw into those problems. Let's say diameter instead of radius, and then you get it wrong. And if you don't recognize that, I'll pretty aggressively take points off, because you're a knucklehead if you make that mistake. You're just not paying attention.
Mr. Evans,
Yes,
why do you cut the 120 in half?
Oh, just.
because it was a diameter, and we have to put radius in that formula. They weren't paying attention.
Should I just kind of know off the top of my head how to convert whatever it is?
So they want you to find it in millimeters per minute, so you're okay. If it's in millimeters, we will do the conversions in a minute, but not for this problem just yet. That's a perfect question to ask. Because they want this answers in millimeters per minute, so we don't have to do any conversions. You can check your answers.
Good one, Slayer.
Yeah, I'm going to be seeing you Wednesday morning, Mr. Evans.
Good. Remember, I record the lessons so you can listen to them as well. That helps. My Alch 2 students are listening to the videos, but not as many pre-calc yet. You guys will. So this one, they want us to change it to miles per hour. Which formula are we using? Linear speed. They gave us diameter again, right? So we have to cut that 16 and a half. So our radius is 8. And it's in miles per hour. Okay? So we get inches per minute for our formula, so we have to convert from inches per minute to miles per hour. Okay? So I'm going to plug into the formula here. 2 pi times 8 times 500. Which equals 8,000 pi. And that is in inches per minute. Okay, I'm going to multiply that 8,000 times pi down here and then do the conversion. So you get 25,132.7. I'll pause. Again, that's inches per minute. And we want to switch to miles per hour. Okay? So we have to do that dimensional analysis is what they call it. That term never really made sense to me. So if I want the inches to cancel, right, because I need to go to miles up here, I want the inches to cancel. So I have to start increasing the dimension, right? So inch to inch, how many, oops, I forgot the 12. 12 inches in one what? 1 foot. And then what goes in the bottom of the next fraction? 5280. You live near Denver, you should know that. In 1 mile. And then we have to do the hour thing, right? So up top, we want hours on the bottom, right? Because it's miles per hour. Miles per hour, like that. So we want that hour in the bottom. So what do I write up top? 60 minutes. And I would multiply that whole thing using parentheses in my calculator. Okay, when you do that, you should get 23.8 miles per hour. Okay. So I would definitely try to multiply that in your calculator. I would definitely give you, even if you set this up correctly and got the wrong answer, I'd give you 3 out of 4 points. right? If you can't plug it into your calculator, you deserve to be punished a little bit, but not like massively. And then learn how to put it in your damn calculator, right? Because it's not that hard.
Just like a fourth.
Just use parentheses and it'll be good. Uh-oh.
No, I didn't. Oh, no, okay. Sorry. I do it like one by one and it works perfectly fine. Or you can put it. No, I do 25,132%. And then I just, so the next number, since all the majority of them are.
Times 60.
No, I do divide by 12, and then divide by 5280, and then times 60, and it gets you.
Oh.
It's just how I see it.
It's okay. It works. It works. That's all that matters. Yeah.
Get the answer.
As long as you have a strategy that works, I don't care what your strategy is, as long as it works.
Half the time I do things wrong, and I still get the right answer, so I just continue.
Why not? All right, read number 6. We'll do it together because you got to do a little more conversion action. So again, we got diameter of 9, so go 9 divided by 2, 4.5. So I did, is that angular? Oops. Hold on, I put the wrong formula down there. I think. Okay, so they tell us 2,800 revolutions per minute.
We're on 6.
We are on 6. And we want radians per second. So that's not that big a change, right? So not as much conversion action. So W equals 2 pi times 2,800. Which is 5,600 pi. And that's in radians per minute. We good? Okay. So then we're just going to multiply that up and then do the little conversion 2 seconds. So 5,600 times pi is 17,592.9. And that's in radians per minute. Right, I'm not writing the diagonal divide, right? Because it's easier to do the conversions if you write your fraction bar horizontally. And then what goes on top of this fraction? 1 minute. And what goes on the bottom? 60 seconds. Okay, and then we have it in radians per second like they asked us to. So that is 293.2. So like I used to freak out about these conversions, and then once you see the fraction, right, as long as you write that fraction bar horizontally, it's not that bad, right? Because you just make sure your units cancel, and then you know you have it set up correctly.
Yeah, that's pretty
Wait, I have a question.
Yep, go for it.
Okay, so if you multiply the pi out from 5,600, would not make it inches per minute. So then why would you?
Because up here, sorry, I went the wrong way. This right here, right? It's in, I should say that, it's in radians per minute, right here. This is in radians per minute. That would be a good thing to write down right there, right? Because that is confusing. That's not a stupid question. That was a good one, right? I would say like units are radians per minute, something like that right up there. I think that would help you make sense of it a little bit. Okay? Units are in radians per minute for this guy right here. I'm not sure why I wrote no radians there. That seems confusing to me. When I relearned my pre-calc, Gina taught me and she must have written that, but I don't see why she wrote it now. Okay, so now we are doing the linear speed on this problem. So like just make sure you know what you're doing, right? The windmill has blades that are 14 feet long. Is that radius or diameter? diameter, right? Because the blade is from the center to the edge of the outside, right? Think about the blade's got to attach like a ceiling fan, right? The blade of a ceiling fan attaches at the center and goes out to the end edge of the circle. It doesn't go all the way across. It's two blades. It is a radius, yeah. Oh, you thought, no, radius. Didn't I say radius?
I said diameter.
Oh, you did? Radius, okay, sorry. I must have thought you said radius. That's funny. Okay. You're like, what the hell's going on?
Life just changed a lot for me.
Okay, let's copy that down there. So I'm writing the formula for linear speed down here. So it's easier to plug in. So we have V equals 2 pi times 14 times 5. And we get 140 pi. Right, so you might want to just multiply the pi right away, but you want to give me as many opportunities as possible to give you partial credit when I grade your tests. Right, so if you show as much work as you can, then I can see if you make a mistake where you did make the mistake. If you just write a formula and write an incorrect answer, I'll take more points off because I can't see your thinking along the way. So just make sure you write as much work as you can possibly show. And then, like, even if you have no idea what the hell's going on, you can still write some stuff down. You might get lucky. It might make sense. If it makes no sense, I'm not giving you any credit, right? But if it makes some bit of sense, I can at least throw you a point or two on the problem because I'm not out to get you. I want you to be, like, if I had a class where everyone got an A, I'd be psyched. I think teachers probably always say that, but. So it's in feet per second. Right, because it was revolutions per second, and it was that many feet long, so it's feet per second. So we want to do get it to miles per hour. So you can do 60 seconds. You can do these in any order, right? You could do the distance first and the time last, or either way, it's totally fine. So 1 minute. And they want it in hours, right? So we got to go 60 minutes in 1 hour. And I'm doing it right because my units cancel. And I want hours on the bottom, right? We want miles per hour. So I know hours are on the bottom, right? So then we have to do the distance with the feet. So where did 5280 go, up top or down low? Down low. 5280 feet per 1 mile. Then it's not that big a deal. You should get 299.9 miles per hour.
Yes, I got it right.
It is really fast. That windmill's going crazy.
That's how fast I'm jumping.
All right, 2 more and then you get homework. We're not writing, I didn't find this helpful, so we're not writing that. Linear speed, I think I wrote the wrong formula again. Yes, I did. So erase this one. They're both linear.
I don't even remember.
I like writing the formulas next to the problem. If you know you're going to have trouble memorizing these formulas, put them on a flashcard. Okay, so ceiling fan with 25-inch blades rotates 40 revolutions per minute, and we want it in feet per second. Okay, so we get V equals, doing linear speed, 2 pi times 25 times 40. And we get 2,000 pi. Okay. And then we multiply that pi in there and we get 6283.2. And that is in inches per minute. and we want to go to feet per second. So you could write the units you're trying to get to over here, and it'll kind of help you. So what do you want to multiply first? Inches. So we'll do 1 foot is how many inches? 12 inches. Good job. And then, so we've got feet on top. We're good on that, right? And then we're going to do minutes and seconds. Minutes up top. So 1 minute is 60 seconds. And then we just multiply all that stuff. We get 8.7 feet per second. Last one. Ryan's riding a bicycle whose wheels are 28 inches in diameter. So I see that right away, and I know I have to divide it by 2 because I need a radius for the formula. If the wheels rotate at 130 revolutions per minute, we want miles per hour at the end. So miles per hour at the end. So we're going to plug that in. V equals 2 pi times 14 times 130, which gives us 3640 pi. $36.40 The hardest part about this is just, I didn't mean to write that, I meant to multiply it. The hardest thing about this is memorizing the formulas. If you got the formulas, you should be okay. If you don't, then you're not going to get these right. So inches per minute for the initial units. So if we do 60 minutes in 1 hour, because we want hours on the bottom, and then we have to do feet to inches. So 12 inches on the bottom, 1 foot on top. 5280 feet on the bottom. And 1 mile up top. When you multiply all that, you get 10.8 miles per hour.
When's the test?
Not for a while. It's good and bad, right? Because that means there's a lot of sections. We got Labor Day coming up. You got Monday off and Tuesday off.
Codes on Monday. It makes sense now.
What?
Is our text
You know the first part?
Your test is the week after. It's fall's just crappy. I think I'm going to do 2-part. So Monday 9/8 and Monday 9/9. Or Tuesday. Sorry, I said the wrong thing. Then my birthday's the next day. 1 through 11 all, bus move. I'm going to come around, check your homework. So make sure you have 5.2 out. Remember, you guys, we have the assignment calendar.
Do we have to do 19?
1 through 11. So no, you don't have to do
So
19.
for the one that's due right now.
It was
1 through 18.
1 through 18, 19, 20, 25, 26. No, 1 through 19. It was 1 through 19. So I was looking at the one before. 5.2 is what you need to have out.
Wait, I had a question.
5.2 was 1 through 19 off. I'll put the homework answers up here. What'd you say? Yep, you can grab it. It's so quiet, I'm like, I'm hearing voices.